In this video, we're going to look at a couple of examples or a few examples that involve arc length, right? So we're going to start off with a couple of examples that are very simple and then one that's a little bit less simple, but all of these are really basic. And then, after this, I think we should be equipped, a little bit better equipped to do some exam examples, right? So let's jump straight into it, right? So we're just going to go actually before we jump into the examples, let's just remind ourselves, right? In the first video, when we're introducing the radian, we said the radian theta, right? And this only works if it's in radians, right? If your angle's in radians, it's a ratio of your arc length to your radius, right? So that means if we're calculating arc length, which is going to be our S, we need to multiply both sides by R. We're trying to get the equation for arc length, which is S. That means S in this case is going to be equal to R multiplied by theta, right? Or if you want to write that out entirely, that's going to be arc length is equal to radius multiplied by your angle in radians. Remember, this only works if it's in radians. You can't do this in degrees. All right, perfect. Right, so now let's jump straight into the examples. First example, like I said, this one is going to be pretty simple, right? Where we have first one line over here, one line over there. You're given a sector of a circle, right? And then let's pretend that this is a perfect circle. All right. And then what we're given is we have 1.8 radians, right? And then we have 2 centimeters. The radius is 2 centimeters. So the question is, what is the arc length, right? So this one is a simple question where we just apply that formula. S is equal to R times theta, right? So if S is equal to R times theta, your R is 2, your theta in radians is 1.8. Then this is going to be 3.6 centimeters. Easy. All right, so that's a simple example in this case. And then let's go to the second example, example 2, where in this case, right, we have, can I do this? No, I wanted this to be a circle. Okay. We're just going to do it like this. We have, I know this is not a perfect circle. We have a radius over here, a radius over there. And you are told that the angle of this is actually 230 degrees, right? And then this is 12 centimeters, like your arc length from point A up until point B is 12 centimeters. What is the radius, right? So initially you'd probably think, okay, right, the formula is going to be S is equal to R multiplied by theta. But you can't really apply this unless your angle is in radians. So in this case, we need to convert our 230 into radians. So in the past couple of videos, we did conversions from degrees to radians, radians to degrees. And the conclusion of that is if you want to go from degrees to radians, you have to multiply by pi over 180. And we went through like the long version of like why, using ratio and all of that stuff. So if you're still uncomfortable, maybe go back to those videos, or at least if you haven't watched them. But essentially, this is the conversion. And we said the hack for that is this is your smaller fraction. It's not one, if you're confused about the 180 over pi, this one makes the number bigger, which means it's used for radians to degrees. Since we're going from a bigger number to a smaller number, we have to use the smaller fraction, right? So we talked about all of this stuff in those previous videos. So hopefully by now, that stuff is not too much of a problem. All right. But if you want me to explain it better, please do let me know. All right, cool. Now multiply this by that. That means for our theta, we're going to say 230 multiplied by pi over 180. Now, if you throw that into your calculator, all right, pi over 180, that's going to give you, a very ugly number. Theta is 23 over 18 pi. All right, so this is what happens when I just come up with random questions out of my head. Okay, but now we go back. So now we can apply this formula. Since now this is in radians, that's perfect. So we have this, we have that. That means now we can find R. In order to find R, divide both sides by theta. So that means our radius is going to be S divided by theta, which is going to be equal to 12 divided by 23 over 18 pi. All right, so if you put that into your calculator, 12 divided by our previous answer, the answer for the radius is going to be, so whether they say, if they say exact value, just work out your, what you do is you're going to say 12 divided by 23 pi over 18, which is the same as saying 12. This is now like, stuff from a while back. If you change your division sign to multiplication, and then you have to flip this around, right? 23 pi, so 12 multiplied by that gives you 216. If you divide it by 23, I don't think you can simplify that, so that's going to be 216 over 23 pi. So the answer to this question is, did I get that correct? I have two different answers here. Okay. 12 divided by 23 over 18 pi. Yeah, okay, that's perfect. So your answer here is this, but then if you have it in the correct format, in decimal format, that's 2.99 centimeters. All right, that was a bit of confusion there, but I think we got there eventually. I'm just going to make sure that this, because this is if I put this directly in my calculation, just make sure that this gives me the same answer. 216 over 23 pi. Yeah, give me exactly the same answer. Okay, so you might be asked to write it in decimal format, or you might be asked to write it in exact format, which means don't simplify. Don't write it in decimals, just write it with like something pi. Okay, as an expression of pi. Right, so that was the second example. Right, so now let's get into our third and final example. I hope all of these, I'm not confusing you too much, but essentially here, we're just using the exact same formula. As long as your theta uses radians, then you're fine. All right, cool. Now, the last example, I'm going to draw a circle here. I'm hoping my artistic skills won't betray me. So we have a radius that comes here, all right? And then we're going to have a line that goes down here, all right? And then another line that goes down here. Okay, so, right, the radius of this circle is actually 3 centimeters. This line, so we'll call this OAB. So AB is actually 4 centimeters, right? So now what we want to do is we're trying to get the area of the shaded region, which is, maybe let me just make this smaller. This area over here. And you're also told in this problem that this angle, OAB, is a 90-degree triangle, right? It's a 90-degree angle. So we're trying to, actually not the area, sorry. We're trying to find the perimeter. Let's just say this is going to be C. We're trying to find the perimeter of ABC. So basically the perimeter from this point down here, there, that perimeter. Okay, so now perimeter of a shape, right? In order to find the perimeter, you just add the points, right? So the perimeter of this shape is going to be, we'll call this P, is going to be the line AB plus, just add up all the sides, right? Plus BC, right? Plus CA. AB is easy. AB is just 4. We were given that value. BC, we don't have that. We're going to need to find it. And then CA, we're also going to need to find it. But we can see that CA is the arc length of this little sector of sector OAC. So let's actually just write this as, instead of writing it as CA, so we don't know this, and then this is going to be the arc length of sector AOC, I guess, yeah. Okay, cool. So now we need to find these two values. So how do we find those values? Let's start off with the arc length, that value over there, right? I mean, not that value, the arc length of this, right? So in order for you to find arc length, S, you're going to need the radius, which we have, that's 3, perfect, multiplied by theta, right? Theta is that value over there. We don't have that. We don't have that right now. So let's figure out what to do. What we do know is that this theta is part of a right angle triangle. So we can use trig to find that theta. So let me just redraw that, that triangle. The triangle looks like this. Not really a very nice right angle triangle, but it will work. So we're trying to find theta, right? We have this as 4, we have this as 3, right? So this is, so we can use, because remember the abbreviation is SOHCAHTOA, right? This is our trig. This is from trig from, the trig expressions, right? So we have an adjacent. If this is our angle, we have our adjacent, right? This is our A. We have the opposite, which is our O. O and A, those use, it means we need to use tan. So that means in order for us to find theta, right, at least tan theta is opposite over adjacent, which is equal to 4 over 3, because your 4 is your opposite, your 3 is your adjacent, which means your theta is going to be arctan of 4 over 3. Now, depending on what now this is the thing that we said in the last video, your setting, your angle setting in your calculator, because you can just put this into your calculator, right? But be careful, because if your angle, since we're working with radians, we're trying to find a radian angle, your calculator setting has to be in radians. So if you put your calculator in, if you put this value into your calculator and you get, let's see, arctan of 4 over 3, and you get 53.1, this is actually in degrees, right? So that's not the answer that we're looking for. If you get this, you might need to convert it to radians, right? What you actually want, right, to make sure that you're in the right setting is actually going to be 0.92725. I'm going to write it like this because we're still not done working with this. So I think we're going to write the exact value, as much of it as we can. So that's our angle. Our angle theta is actually, or we can actually just like leave it like this for now, right? Until we get the final answer. So now that we have theta, now we can use the arc length equation. R multiplied by theta, which is 3 multiplied by, because our R is 3 multiplied by this value, I'm just going to write it as arctan of 4 over 3. So that's our S, right? So we now have a value of S over here. So let's just erase this. So this is going to be 3 arctan of 4 over 3, or you can write it as 0.92. That's perfectly fine. The only thing that we're missing is BC, right? Now BC is this line over here, but again, you also notice that this is part of the hypotenuse of the triangle, but it's only a portion. So we need to find O up until B, right, which is the whole hypotenuse. But we also know that from O until C, this is actually 3 centimeters because this is the radius. So if we take this whole AB and we just remove that radius, we'll be left with this portion over there. So the equation that I'm going to write on the side over here is actually, in order for us to get BC, we need to find OB and then subtract the radius, which is OC. Now we know what OC is. That's our radius. That's 3 centimeters. The question is what's OB, right? What's that value? What's that whole thing? But you can see that this is O, this is B. So we can use Pythagoras theorem to get that whole hypotenuse. So OB is actually going to be, just to avoid confusion here, So we know that value from Pythagoras, we know that a squared plus b squared is equal to c squared or r squared, whichever, notation that you use. And this is always going to be your hypotenuse. So in this case, to get OB, that also means c is equal to the square root of a squared plus b squared, right? So to get OB in this case, it's going to be the square root of 4 squared plus 3 squared. Essentially, to get this hypotenuse, you take the opposite squared plus the adjacent squared, and then your square root. If you put those into your calculator, you should get 5. So your value for OB is 5, which means BC is your 5, which is from this point all the way up until that point. But remember, we only want this little portion over here, right? So we need to remove this portion over here, which is your radius. So we need to remove that 3. So we subtract from 3, which means the value BC is equal to 2. So now we have BC. So we can come back into our equation and put the value 2. And all we just need to do at this point is just throw these into our calculator. So 0.92 plus 2 plus 4. This is going to give us 6.93. So our answer, I'm just going to write it here, is equal to 6.93. Let me just put a little bubble over here just to show that this is all working. But yeah, this is a very good example because it starts to get you to start thinking critically, right? Where you're mixing different concepts. Trigonometry, you've got your, looking at different shapes and breaking it down, because this is it's closer to what you're going to get in your exam, because in your exam, you're not just going to get a circle and asked to find, the arc length. So this is a little bit closer to the level of, thinking and breaking down the problem that you'd be expected in your exam. So we'll do a lot more of these in our exam question videos. So I hope I see you there, and I hope these questions so far made sense.